So we're going to kind of go through some application photos and kind of just, if you have any questions, now's the time. Computer room air conditioner, set point can now be raised. So what we're trying to do is, instead of the whole process is, instead of having the conditioned air mixing within the cold aisle and then having to get pulled through the mesh front door, go through the equipment, and then get out the back of the cabinet in the hot aisle, that's traditional hot aisle, cold aisle. We're trying to minimize that and slowly push those two, the hot aisle, cold aisle, into the cabinet. Therefore, you don't have to cool the whole room, just cool your equipment. That's the whole purpose. The better you can get that cold air to your equipment, that 70% bypass starts getting minimal. So with inside the enclosure as well, now you have to manage the hot air. How does that get out? Via either a split mesh door or a split fan door, assisting just the front cold front to back draw going into the hot aisle, or using a solid door and ducting the hot air right into your return plenum. Therefore, you have no recirculation in the data center at all. So the whole data center has no heat generation in the room. It doesn't recirculate, it doesn't go through it. The brushed grommet kit with inside the enclosure keeps that from recirculating back with inside to the front air tape as well. Some more application shots. What I want to show is that this application uses the air manager in the bottom. There is a hole underneath the enclosure. The enclosure is sitting right on the floor. There are no casters, there's no levelers. And using the air manager, and there are no perf tiles in this whole data center. These floor grates simply are for the room cooling for personnel only. The facility uses airside economizers, so it's free cooling. It runs 90% on outside air. This is in Pittsburgh.
Is there a big problem when you open the front door?
Actually, no. The front door is a mesh door.
Okay.
So it's not relying 100% on that. It's still getting, but what it's doing is dropping the air intake approximately 5 to 8 degrees, and sometimes even more than that. But it's not relying 100% on that airflow going through there. It's still getting a mix of the room. Instead of the mixing happening in the cold aisle, the mixing is happening inside the cabinet right in front of the air intake of the equipment. So instead of having, usually there is a temperature increase from the cold aisle through the mesh door right to where the air intake. So we're kind of reversing that now. This actually shows the rear of the enclosures. They're still just, the grates are just for the personnel. It has a full ducted return. The whole drop ceiling is ducted into the crack unit. So that's where all the heat generation is going through. Sorry,
No problem.
Typically, would contain a hot aisle with a mesh door for exhaust. But what we're seeing here is 65 to 68 degrees in aisle spaces, 60 to 62 degree at the equipment intake. So now, typically, that's usually reversed. You know, a hot aisle, cold aisle. The coldest place in the room is in the cold aisle where you're standing, not where the equipment is. We want to reverse that. Still showing some other applications with this. This is typically what you would think would be the cold aisle. These are all the air intakes, and the air managers are all in here. But these cabinets support the cable management overhead. All the data is overhead, all the power is underneath. This is an 18-inch raised floor. So this is just to show some of the ladder rack, basket tray, cable troughs that the cabinets actually support. So there's a cost reduction of the facility as well, even the initial build, that you don't have to have the cable management installed by a contractor, having it suspended from the ceiling by whatever method there is. There's various methods. We're now using, you already have a structure there. It has enough support for it. Use that for the cable management. And many different variations of it. You saw a ladder rack here. This is an aluminum tray. This customer wanted a specific height for where else he was going in the room. So we made a custom ladder rack brackets for him, and they have the waterfalls. And all the cabinets have various cable access points in the top panel. On a 24 wide, it comes through the center of the top panel. On a 30-inch wide, you're able to bring it to the sides and stay outside the IA pattern. And that way it keeps it much cleaner for airflow. And one more for cable management across the top. And this is actually a basket tray. And these are standard enclosures with the standard ladder rack type brackets, we'll call it.
You can see by all that cabling, if that was all underfloor, how much it would impede airflows. Having it above is a benefit.
And the reason why we do that is because it does jump the aisles every so often. And every time if that was under the floor, that would be a block. What we're looking at is above the drop ceiling, where these are the hot exhaust return from the ducted return. And this whole plenum above it is the hot return. We're just showing some different layouts that we can do. We assist in looking at your room, kind of maximizing your floor efficiency. So we can assist in laying out just even physical real estate space. But considerations of that. Sure.
If you go into an area and set up a unit or a room like this, and you duct your hot air up into a ceiling space, how do you exhaust that hot air in that existing ceiling space?
The crack unit
have to make some type of provision for that.
The crack unit is the building, and when they're building that facility, they are ducting, they're drawing in from that.
This facility is already built, and you have no provision for that. How do you get it out? You have to make provision somehow?
Well, like I said, every data center is different, so we have to evaluate what your room is, where your crack unit is, and what's the best way to get it to your crack unit. Via just a chimney where it doesn't go into it. We're making a data center now where the chimney is just 5 feet high, just to get that up and above the air intake, because they have an 18-foot ceiling. So we're just trying to get that away from the air intake and just get it directed to the return. So each one is different. But looking at standard hot aisle, cold aisle designs, everyone's seen this shot. Pretty common sense thing.
Most important thing was the bottom part in red.
All right. No perf tiles in a hot aisle. Everyone thinks, oh, I got a data center and I'm walking through, oh, this place is hot, I better start putting tiles in it. You're wasting money right there. So if you have a perf tile in the hot aisle, get it out.
Well, you may have been approached by people talking about putting walls up over here for air recirculation and things like that. First thing to do is look to see if you have air here pushing up, because if all your air is pressurized here and this has greater air pressure than this won't come over. So take out some floor tiles, you might save yourself a ton of money buying those overhead containment doors and so. Sorry.
No, and really that's what it comes down to, is just common sense of keeping your hot and cold separated via whatever method. And there's very simple methods there, and there's very complicated methods and very costly methods there. But we feel that you can get 90% there by just doing common sense parts, rather than spending a lot of money. So we just kind of run through some cooling concepts and just as our methodology of thinking here. Standard hot aisle, cold aisle is a front and rear vented doors. Optional fan assisted, but you still have a standard hot and cold aisle pulling a horizontal flow. So typically you see 63, 68 in the cold aisle, 65 to 72 at the server intake, typically at the top half of the cabinet. It might be cool in the cold aisle, but if you measure right inside there, it actually there is an increase. So another cooling concept would be to take a standard cold aisle with a ducted exhaust. So now we're eliminating all that the heat generation inside the room. So you're eliminating the recirculation over the cabinet, around the aisles, and just making sure that gets out, whatever method.
Again, the back is solid on that?
Now this is solid. But as you can see, same pretty much at the cold aisle, server intake, and really what you're gaining is efficiency out of the crack unit. So now we have a plenum air manager with a ducted exhaust. So now what we get is 68 to 72 in the white space, and now 60 to 65 at the server intake. So those two temperatures now are reversed. So now I'm able to get a bigger delta T across my equipment, so I have a greater heat load that I can install in this enclosure. I have a greater cooling capacity of this enclosure because I have a cooler temperature, and yet my temperature of my exhaust stays the same.